Welcome to Webinar Wednesdays. We're glad you could join us for today's webinar, Using Visual Representation or Models in Teaching Fractions to ABE Students. We know our ABE students struggle with fractions, but why? Today, Ronald Cruz, our facilitator, will provide some insight and tips on how to teach fractions in a more concrete or illustrative manner. When students obtain a comprehensive grasp of the math concept, it is easier for them to apply it. I hope you enjoy the webinar. Please feel free to ask questions in the chat bar. And remember that all webinars are recorded and archived for you to share with your colleagues or review again later. I encourage you to visit the IPDay website often and regularly. There's a lot of great resources on ABE Mathematics like lesson plans, videos, archived webinars, workshop-related materials, and a lot more. So now at this point, I'm going to turn it over to you, Ron. Enjoy your day.
Thank you, June. Welcome, everyone. It's me again, your Florida IPDay State Trainer for ABE and GED, specifically in mathematics. I really appreciate you joining this afternoon's webinar. Hopefully, you will gain some really useful that you can use with your students when teaching fractions. So by the way, for those of you who do not know me or it's your first time joining one of our webinars, my name is Ron Cruz. I am the coordinator of the Caribe Refugee Program here in Tampa, Florida, part of Hillsborough County Public Schools. And I also do a statewide training and development throughout the state of Florida for ABE Math and GED Mathematics. So without further ado, our topic for today is using visual representations or models in teaching fractions to ABE students. Let me just underscore the importance of the concept of fractions to all teachers, not just ABE, K-12 teachers, GED teachers. They struggle, in particular, students struggle with the concept of fractions. They don't understand it. They do not know how it works. They gain, if they gain something out of it, it's just the memorization of algorithms and steps that we teach them, but they do it so blindly that they don't understand what's happening to the quantities that they're working with. So for this webinar, our objectives are to, again, improve overall student achievement by focusing on what content standards we have to teach and what standards of practice we have to exercise in the classroom. And in particular, involving the ones that are useful to the teaching of fractions. And of course, this webinar is going to be aligned to our college and career readiness standards for adult education. What you're going to see this afternoon is a more visual approach to teaching fractions rather than your traditional way of teaching fractions. I'm going to show you a much more visual, easier approach, a little bit more user-friendly to your students. And I guarantee you'll get more engagement with your students, and your students will walk away with a better understanding of fractions if you teach them in this manner. We're going to apply one specific mathematical practice standard in this webinar, and in particular this is going to be the MP4, which is modeling with mathematics, and I'm going to explain that to you and what that standard means. And then we're going to be looking at the resources, what's available in the IPDay website, what's available on the internet. Are there things that I can use as a teacher if I have access to technology, if there's something out there that I can use to help my students understand fraction. Just to keep in mind, we also have some people that are working in the corrections that are participating in these webinars that we do through IPDay. And I just wanted to let everyone know that anything that I introduce in these webinars in terms of technology, links to website or software, can be easily duplicated into paper format. If you want the templates, you can explore all of the myriad of resources that have been posted over the IP Day website under the ABE CCRS ABE Math column or tab. All right, so let's ask this question. Why do students struggle with fractions? Have we thought about that? I'm sure you've seen this face before that you see on your screen. You know, they get it for one, you know, they look at it, they seem to be understanding it, and then they forget about it. You know, that's the usual struggle with them because fractions is not something that they encounter on a constant basis as compared to whole numbers, as compared to percents. Fractions are a little bit less, a little bit more uncommon to them, and let alone that notation is uncommon to them. The vocabulary, you know, when we teach fractions, it doesn't only come in with just the notation, it also comes with all of these other things like numerator and denominator and lowest terms and things like that. Students get bogged down with the vocabulary, especially those students that are moving from ESOL and going into the ABE classroom. This becomes a stumbling block for them as well. There are several rules that we have to follow in fractions, and that's what's bothering the students so much because they don't have time nor the energy or the enthusiasm to memorize these rules, to follow these steps. So that's another factor that is contributing to their struggle with this particular concept. And another thing, to add to that, fractions don't behave like normal numbers, you know. When you multiply a whole number to another whole number other than 1, the numbers get bigger. Well, if you multiply a fraction to another fraction, let's say if it's a fraction that is less than 1, if you multiply two fractions that are less than 1, the resulting fraction is much smaller. So it really is like something different. I mean, it's a complete reverse, a complete 180 of what they knew when they were taught, you know, in early grades on how to operate on different numbers. So fractions behave very differently, and so the quantities, the resulting quantities, are also very different. And then we go into the more difficult portion because fraction is not just a bunch of numbers put together with a bar in the middle. There's a lot more deeper information and a lot more concepts happening to a piece of fraction than what you think, you know. Fraction can be looked at as a division problem. You know, students can look at it and it's a division and it turns into a decimal. Perfect. That's one interpretation of fractions. And another interpretation of fraction is as if it is a part of a whole. And if you use and you try to reconcile these two different understanding to justify the rules and the steps that you're trying to teach your student, you're going to find your students very lost. So what we're going to do is we're going to try to separate these two things and focus strictly on them one at a time, which is the best practice in teaching fractions, is not to delve into both nature of fractions, but just to look into one. Now, if you look at the bottom of the screen, you'll see a really important resource here that I got a lot of the explanations that I'm using in this webinar. It was published by the National Research and Development Center for Adult Literacy and Numeracy, written by MacLeod and Newmark back in 2006. And if you Google this piece of information, you'll find a myriad of resources that will help you explain little nuances in the area of fractions when you're teaching fractions to your students. So that's just a little side note before I move on. So again, why do students have to learn fractions? Okay, well, that's already a given. Fractions, even though they're uncommon, they are integrated into the real world of math. You know, they're automatically being used in specific workforce or job fields. Data handling, sorting, measurement, time, volume, probability, all of them can be expressed, if not strictly expressed, in fractions. Again, in different specializations, money problems, okay, well, I'll pay half the bill, or I'll share with you a quarter of the bill, or, oh, I'm going to a specific location, but it only takes 2/3 of the time to get there. You know, those are the things that we kind of use to kind of estimate what we wanted to do and or estimate the quantity that we're talking about or to describe a particular item or unit. We use fractions more than we think we do. So therefore, we need to understand what it is so that we know exactly what we're talking about, because we can easily mislead other people when we misuse fractions or we do not know and do not quite understand what the fractions means. Like, if it takes 2/3 of the time to get there, does that mean, does it take me longer to get there, or does it take me less time to get there? So that's a question that even my students are struggling to answer because their background on fractions is not very strong. So then I start with, you know, the basics. And good thing about the College and Career Readiness Standard is that we have a mathematical practice built into the standards that we have to use with our students, which is modeling with mathematics. And this is where I'm going to start off with, and I really suggest teachers start doing this as well, is to start with the model rather than jumping in straight into the algorithm or the steps on how to add, subtract, multiply, divide. They need to truly understand what fractions are if we want our students to be successful in working with them. So modeling with mathematics is so wordy in here in our standards, but I kind of highlighted those very important things. When we ask students to model mathematics, we want them to identify important quantities, take away the unnecessary quantities, and use the ones that are needed to solve the problem. And then once they've identified those quantities, they must be able to map those quantities or establish associations with those quantities. In establishing those associations, they need to be able to analyze exactly the relationship between two different quantities in order for them to draw a conclusion, which is usually the final answer to any ABE GED question that involves fractions. Routinely, they would probably interpret the results or maybe use the numbers that you got from your answer and then determine what it means. Going back to just like the example that I said, if your answer is it's 2/3 of the time to get there or to get to a particular location, does that mean am I going to travel longer or am I going to travel shorter? So let me give you some examples of modeling with mathematics. First is writing an addition equation to describe a situation. So in here I'm going to depart and I'm going to go broad, and I'm not just going to concentrate just on fractions because I wanted to show you that the mathematical practice 4 doesn't only apply in the concept, in teaching the concept of fractions. So writing an addition equation to describe a particular situation. So for example, we have 30 participants and 30 participants and 4 of them are boys. How many are girls? So can you write an addition equation to describe that particular situation? That's what it means with that particular example. Applying proportional reasoning to plan a school event. So one example is, okay, well, if we're trying to sell tickets to raise money, and then we're saying if one ticket costs, let's say, $45, how many tickets do we have to sell in order for us to make a profit of, let's say, $2,000 in order to buy something for our club or in order for us to fund a particular school event? So you're going to require the use of proportions. Set up your proportions and then treat them as if we're working with fractions and then go from there. Another use of proportional reasoning is when you analyze the problem in a community. You know, let's say, for example, 60% of the county's population uses a particular road or street. How big should their roads be in order to be proportionally, in order to be proportionate to the population that travels on that road or on that street? These types of situations and scenarios that I'm giving you are, a lot of these are real world examples that they will be using, and they need to be proficient with, especially when they go into the GED, when they're taking in the GED test. Yeah, we do geometry a lot. So geometry is already a model of mathematics, or is a direct manifestation of modeling with mathematics. Using a function to describe a relationship between two quantities in an observation. So we're going to cover this modeling. Actually, I've covered this in the past when we solved sample problems, sample GED questions. We often use an equation placed in a function notation in order for us to work with them. And then sometimes students are asked to approximate or estimate, not in the GED, but on the TABE test. Students are asked to approximate or find the approximate or find the estimated amount of a particular item, and then use it and simplify it to answer the question. And then using a diagram, using tables, using graphs and floor charts and formulas. When students use these things or use to draw information out of these representations, then they are actually using modeling with mathematics as a practice. So I'm here to give you some tips and tricks in teaching fractions. So I've labeled this slide, what teachers need to keep in mind when teaching fractions. So just like I told you, there are two different ways of looking at fractions, and one way of looking at fractions is to put it in this format. Learners should understand that one way of thinking about a fraction is to see it as a result of dividing the top number equally into the number of groups shown at the bottom. Let me give you that as an example. So I'm going to write here, let's say we have 8 over 2. It's an improper fraction. The numerator is greater than the denominator. All this means, item number 1 means is that we're going to take 8, let's just say I'm going to draw 8 circles, and we need to group them into groups of 2. And then the resulting number of groups will be your answer. So if you group them into 2s, how many groups do we have? That's 4. That's one way of looking at fraction, is the number, the numerator tells you the total number of items you have, and the denominator tells you how many of that has to be grouped. Another way to think of fraction is that the denominator is the total number of equal parts of one whole or one set, and the numerator is how many of those equal parts there are. So this is our traditional interpretation of a fraction. So for example, we have a bar of chocolate, and then the chocolate is, let's say, divided into 5 equal parts. Pardon my, my drawing, but I'm trying to shoot for 5 equal parts here. And then, so let's say we ate this much. So how much, if you want to express how much we ate into a fraction, we just put the number of parts that we ate equal to the total number of we ate over the total number of equal parts we had in the beginning, which is 5. That's one way of looking at fractions. So you see how these two, number 1 and number 2, could be looked at and understood very differently by students. That's why I ask, what I'm suggesting teachers do is to start with, you don't teach these together, okay? And then start with this, you need to start with the modeling of the fraction as a part of a whole first. And then when the students become more proficient in this, in the understanding and representation of fractions in this format, and then you introduce to them the second interpretation of fractions. Okay, so I'm going to show you another trick here, and or another tip that I have, and after this I'm going to pause for some questions, just in case some of you have any questions. Just so you know, if you have any questions, you can always use the chat bar or the chat toolbox in on your screen, and you can type in your question, and I'll be able to see those questions, and hopefully I'll be able to get to your question and answer them, you know, for the duration of this webinar. So the third tip that I would give teachers is they need to be familiar, students need to be familiar with the different types of representations of fractions. Okay, fractions don't always look the same when you represent them, and in the GED or in the TABE test, they're always represented in different ways. And so we need to expose our students to the different representations. Now I'm going to show you some of the common representations that we have. This is the very basic and the most common representation we use with the students. We have a whole circle, and we cut the circle in half, and then we cut the half into halves again, and so we get fourths, and then we shade to show the different fractions that you can form out of a whole. Now this is very basic. Students learn this type of representation of fraction on in the elementary school, you know, from first grade to fourth, fifth grade. So this is how they see fractions at those levels. Now by the time they get to fifth, sixth, seventh grades, they should be familiar now with a different representation of a fraction, which is in a more rectangular format. This becomes useful because then students are now going to start working with coordinate planes and lines and functions and things like that. So a more quadratic or a more rectangular representation of different fractions is more appropriate at that level. Okay, so we're going to look at it and say, okay, well, this students must be able to make the leap between the two representations of fractions that we have here that show the same thing, you know, and in order for us to show 3/4, that we need to shade two more, and then now we're going to be able to show that this is no longer 1/4, this is now 3/4. Now let's go to the next representation. Look at this. This is a more real-world representation of fractions. Because students will not see fractions always in perfect squares, rectangles, and circles. They usually see them in volumes, in lengths, and things like that. So we need to expose students to the different fractions in different scenarios or in different situations, such as in this case, we have cups filled by colored water to show different fractions. So a fourth doesn't always have to look like this or like this. A fourth can also look like a fourth of cup. So this one combines a little bit more of the estimation skills and understanding of volumes, but it's still fractions. And then this one is the rarest of them all. Students rarely see fractions on a number line. And no wonder when we ask students to do, okay, well, when we ask students to plot points on a coordinate plane and when the numbers or when the ordered pair are in fractions or in decimals, they always struggle. That's because we didn't start from the beginning. When we teach students fractions, we need to also show students that fractions also exist on a number line. And and there's a lot of conversation that can be generated out of this. Students can look at this number line that we have over here and look at how the denominator stays the same, but as the numerator increases, so we're going to start, this is going to be our start, but as the numerator increases in value, it gets closer to 1, okay, but as it exceeds the number 8, which is our magic number right here, as it exceeds the number 8, the further it is from the number 8, you go further from 1 as well. So the same understanding as when you're looking into, remember negatives, positives and negatives and absolute value, the same concept can be applied to fractions when you're teaching them the fractions. So again, it is very important to show students that fractions or how they exist on a number line. And then you'd be surprised how easily students can plot fractions, ordered pairs that involve fractions on a coordinate plane if you've already exposed to students how fractions are on a number line. And there's so many applications and problems that you can solve using the number line that requires very less steps. It just needs a little bit more understanding of fractions. Less cumbersome for some of our students. These are some of the other representations. We also need to show them that, yes, fractions have decimal equivalents. And then one way to establish the understanding between the relationship between decimals and fractions is just show them these sets of fractions that I have here. You can use the same exact fractions and have the students formulate rules or figure out patterns. What happens to the values of the decimal as the as the denominator increases in value? That's, we need to stop and think and, do some quantitative analysis with our students and see, oh, okay, as I increase the numbers in the denominator, my decimal equivalent decreases, and then some of my students would say, well, as I increase the number of zeros in here, well, I'm also increasing the number of numbers after the decimal point, which is an excellent, excellent observation for students to have, because that will give them a clue as to why we have all these rules when we multiply decimals. So you're already teaching them skills on decimals. You're not there yet, but you're already teaching them foundational understanding of decimals as you are already teaching fractions. Oh, here's a more advanced way of showing fractions. Is to show the decimal equivalent and to show the percent equivalent and to show the fraction, of course. But looking at this, you have multiple representations here. You can show 1/2 in here, and well, this can also be in here. They don't have to be all together. For example, this 10% right here, I can do another 10% here, but it's going to look a little different. So I'm going to shade this. Oh, it's very difficult for my pen to do this. Okay, so hold on. As long as I have the same number of shaded blocks, so I have the 4, and then I'm going to put another 4 right here. 4 blocks. And then I have 2 more remaining, so I'm going to shade 1 block right there. And 1 block right here, just randomly picking. Okay, so let's just say, okay, let's just not think about that. Let's just see if we only have this in the picture. Would the students be able to determine how many percent of the squares are shaded if the squares are shaded in this manner and not so much as this manner? So see, the understanding of fractions is actually useful when we're looking at ratios, when we're looking at proportions and things like that. And fractions don't always have to be arranged in a perfect array of blocks. Okay, they could be as disorderly as this and still mean 10%. And then lastly, of course, we want to show them equivalent fractions. So if we draw the fractions like these and represent them in this manner, students can see, oh, it's the same quantity. So 1/3 and 2/6 and 4/12, the shaded region in comparison to the entire block is the same amount. Okay, so I'm going to pause right here because I think I've given you a lot of suggestions and ideas and some explanations here. So I'm going to pause a little bit and just look at some of your questions. Okay, so give me a second to just read some of your questions here. I'm not going to be able to answer the technical questions. If you have any difficulty, we have somebody working in the background to address those questions. Okay, the first question here is from Joseph Tucker. He asked, isn't division and dividing into parts the same thing? It is the same thing, but it could also be interpreted in a different way. And what I'm going to show you, and you're going to understand that when I give you an example on explaining on my as to why you had to flip and change the operation, flip the second fraction and change the operation when you're dividing a fraction by another fraction. There's two different explanations for that. Yes, what you're saying is correct, but that's not the only way to explain division. And then Joseph Tucker again, and I really appreciate your feedback here, Joseph. Do students really need to be taught more rules? I find it more effective for them to execute the division problem to find a decimal representation of the same value. They can then construct their own appropriate level of understanding after that. That is correct. One way that teachers do it is just teach them using the division concept and have the fraction play out on its own, and then or have the students understand fraction based on their understanding of division. That is exactly what we are talking about and we're suggesting here, Joseph. But thank you. We really appreciate your feedback here. All right, so moving on. Okay, another visual representation of a particular fraction. So let's look at the picture on the left, okay? On the left side, you have, graphs. You have the x and y axis. So let me label that. Let's just the x and the y axis over here. And then now you have diagonal lines. So I know this is going to be a little bit advanced for some of the ABE level, but now I'm talking to some of your GED teachers that are tuned in. Let's just say, okay, ABE students, they don't need the equations of the lines to represent these, but for GED, they might give you the equation, okay, y is equal to x and y equals negative x over here. And those are the equations that represents the diagonal lines that split the square into 4 equal parts. But then if you superimpose the x and y axis, we now have 8 different parts of the square. Now if I want to represent 1/2, I don't have to represent 1/2 by shading the normal way. I can represent 1/2 like this. And let me pick that, let me pick that, and let me pick that. And then I can say 1/2 of the square is shaded in red. So like, oh, okay, well this is 1/2 too. Yes, a lot of the students don't realize that if it doesn't look like the normal 1/2 that they see in the book, it's not 1/2. So that's one of the myths that I wanted to demystify for the students when I'm teaching them. Now look at the picture on the right. So tell me, okay, so we're going to use your chat box, and you know it's time for you to practice your chat box. I'd like for you to type in on your chat box the fraction that would represent the white region of this figure to the right. So I'm going to pause for a little bit and ask you that question. You can type it on your chat box, and I'm going to wait. So again, let me repeat the question. Okay, and I'm going to rephrase it. Use a fraction to represent the region, okay, to the right, on the picture to your right. How much of that picture is shaded in white? Ooh, I see some answers here. Very good. I got 2/3, 4/6, 4/6 or 2/3. White region is 4/6. Very good. I get a lot of correct answer. Very good. You're really right on top of it. Be surprised how many students will struggle with this particular question. Why? The reason is that this is really not normal to them, because what they're really expecting is something like this. Oh, wait. Let me go back to the slide. What students are really expecting is something like this. Something that is uniformly, divided and then shaded in white. And that's really unfortunate, because students must be able to, in their imagination, or draw imaginary divisions at the bottom half of this. A lot of I've had students that only focus on the top, and they said, oh, the answer is 1/3, and they're proud of it, and they fail to recognize that we're talking about the entire we're talking about the entire diamond or square here that we are looking at. So they fail to look at the bottom, or they don't know how the bottom is to be divided equally in order to answer that question. But really, great job, teachers. I think that you see what I'm talking about when I tell you not every student are exposed to this type of mental exercise just to test their understanding if they know or they really truly know their fractions. Okay, so let's try this. So use your chat box, and I'm going to ask you this question, and you can type. Your answer might be a little longer, but try to be brief with your answer. I'm going to give you a few minutes to tell me, to explain to me which one is greater. Is it half of a small square or a quarter of a larger square? I'm going to give you some time to draw on a sheet of paper if you need to, or I'm going to give you some time to type. You don't have to fully explain it. I'll just read off and explain your idea once I've read it. Okay. I'm getting some really interesting answers over here. Very good. And this is the type of response that I would like to get from this webinar. Very good. Okay, so here, let me read off some of the answers here, and I won't reveal who you are. Okay, I'm just joking. All right, so one answer is one person said, oh, the half is greater. Another person said a half is always more than a quarter. Yes, that is partly true. Half of anything would be bigger than a quarter of anything. That is still partly true. they are equal. That can be true, okay? That can be true for certain cases. Another person that depends on the square footage of the squares. That is the correct answer. It depends on the relative sizes of the squares. You have no reference here because you don't know how large is the larger square. And let me explain to you what we're talking about here. Okay, so one case is that you have a small, okay, hold on. My slides are moving ahead of me. So I could have a square, the small square that is like this, and then I have the larger square proportional, well, yeah, I could have a larger square like this. And see, if you do a half of a small square right here, and then if I do the quarter of this larger square, do you see how they cannot be equal at the same time? Or do you see that the larger square would always be bigger than the smaller square? The quarter of the larger square would always be greater than the half of a smaller square. And I could show you the reverse too, and I could show you when they're equal. Let's say, for example, this is your small square. Okay, and then let's just say your larger square, I'm just going to extend it like this. Pardon, my stylus is a little shaky because let's just pretend that this is a perfect square right here. So then let's say the quarter, this is an example where the quarter of the smaller square, which is this is a smaller square, and this is the larger square. This is the case where they can be equal. Okay, and then I could also show you when they could be less. So it really depends on how big each one is. Okay, there's not one right answer here in this particular question. I'm not trying to trick you, but this is a really, really good mental exercise for your students. It's a higher level thinking, critical thinking skills that you need to teach your students so that they can maneuver through different nuances of the TABE and the GED test. Because you never know what they're going to be asked. You can teach them all the question types all you want. Spend all day teaching drill sample questions and drill them with sample GED practice questions and GED ready questions. You can do all of that, but if you teach them how to think and how to analyze, how to draw, and how to model, you will go much further with your students. And you'd be surprised on how they can model different things with you if you just allow them to do that. Now here are some other teaching points. You know, remember and these are very standard, we do this with our students a lot. Make sure that you, when you're comparing, you ask your students to compare unit fractions, you know, or meaning fractions that are in simplest terms. Okay, and then when you're comparing fractions, start with comparing fractions with the same denominator before moving to fractions with this different denominators. And also, I also try to do with them is comparing fractions with the same numerators and see how the rules and the patterns for that is quite different. I also want you to encourage your students to determine whether the fraction is already in simplest form or not. You know, and then a lot of my students, they really, really benefit from this technique that I tell them. You can gauge the size of a fraction by comparing it to a half. Is it equal to a half? Do you think it's less than half? Or do you think it's greater than that? It's a very simple mental exercise that I do with students, and it really teaches them to understand fractions a little bit better. And then consider the difference between a fraction in simplest form and a whole number, just in this case 1 minus 1/4 or 1 minus 1/5. Have you started looking at the pattern of answers that we're going to get out of this? Now, when your students are already proficient, let's start with that first one that I circled. You know, this is the normal or the more traditional way. We're going to have to rewrite that whole number into a fraction. 4 over 4 minus 1 over 4 is equal to 3 over 4. And if I do the same procedure for the other one, it's 5 over 5 minus 1 over 5 equals 4 over 5, or 4/5. Now, I can do this many times with my student. Usually, I would do it 1, 2, and 3 times. So the third example that I would give my students is 1 minus 1/3. And then I ask them, okay, without doing all these steps that I did, rewriting the fraction, subtracting the numerator, and then copying the denominator, based on these examples that I gave you, can you make a generalization as to how you're going to get something if you're subtracting by the unit fraction? You know, without going through all those steps, can you give me like a quick technique or shortcut? So in my classroom, I don't teach the students the shortcuts and not explain to them how that shortcut works. If I can't explain them the shortcut or why it works, I don't teach them the shortcut. But the more effective way of doing it with your student is have them come up with the shortcuts and have them explain to you their thought process. Number 9, I want to be able to show you that the fraction can be, you want to be able to show to your students that the fraction can be written in an infinite number of equivalent forms. So 1/2 is equal to 2/4 is equal to 4/8, and so on and so forth. So there's going to be an infinite number of ways you can show 1/2, and students must be able to understand that they're all equal to 1/2, and this is your unit fraction. And then lastly, show fractions can be equal or bigger than a whole. So just like the example I gave you earlier, 8/2, that is greater than a whole. You can either do that in a division way when you're going to result with a whole number 4, or you can just illustrate 8 divided into halves. Okay, and then the $1,000,000 question, why do we change the multiplication and flip or use the reciprocal of the second fraction when dividing fractions? So before I talk about this, just keep in mind that what I tell my students is everything that we do in math is the reason why we do things in math is because it matches what happens to the real world. What we do is we use math was invented so that people can work with real world, quantify things and do things with those quantities and be able to predict the resulting quantity without having to do it first. That mathematically we can figure it out. There are many ways to explain this answer. What I'm going to show you is only one way, and the one way that I use with my student, it works, and it kind of stops them from asking, why do we have to do all these steps? Well, more importantly, they stop asking for the steps and they start figuring things out. So let's start with, if we have one whole, so this is the 1 right here, and we wanted to divide it into 6, and this is the representation. Okay, so we divide it into 6 equal parts, and then how much is this a part? And that part is 1/6. So I'm just setting up the illustration on how I build towards explaining the flip. I started off with whole number divided by a whole number. And then I tell them, okay, well, look at here. When you divide a whole number by a bigger number, you get a smaller number. Okay, would that be true when you're dividing fractions? So that's a really good question. So let's figure that out. So moving along, what if we have to divide 6 into halves? Well, okay, well, show me half first. Well, okay, well, remember when we did 1/2 from 1? So if this is 1/2, it's right here. So this should be 1/2. Okay, so that's your 1/2 mark. This quantity is 1/2. So then this quantity is another half. Okay, so all I have to do is every increment of 1, 2, 3, 4, 5, and 6, we just cut it into 2. All right, now this division question is asking if you divide 6 into halves, how many halves is your result? Well, let's count. I'm going to try to use a different color of pen. Give me a second. All right. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer is 12. 12 1/2 pieces. Okay? So if we do this the normal way, we're going to write it like this. Okay, and then after that, we're going to tell them, okay, well, 6 over 1, you're going to change the operation to the multiplication and take the reciprocal of the second fraction, or your divisor. Oh, that's 12 over 1. Then I tell them, okay, you multiply across. Sometimes my students would be confused. Do we have to multiply across or do we cross multiply? And then so I tell them you have to multiply across, numerator to numerator, denominator to denominator, and then you have something like this. When students, they always see, okay, if the denominator is 1, then you can just eliminate it, or in their own words, cancel it. In this case, the answer is the same, but I was able to come up with the answer in a much more visual fashion and not getting lost within the steps, the nuances of each step. You know, the reason why we have to flip and multiply is for us to be able to model the same thing that is happening on the number line when you're dividing the whole number 6 into halves. So in order for me to be able to get 12 pieces out of this problem, in order for me to get 12 pieces, the only way I can do that is if I multiply the denominator to the numerator. And this always works in this case. So then we use that method, the method of changing the operation to multiplication and then flipping the second fraction was created to mimic what is happening in the division on the number line. Let's take another example if that's not too clear. So again, we have the same number 6 right here. And this time we're dividing it into 1/3. So first let's identify what 1/3 is. So well, if this is 1, 2, 3, 4, 5, and then 6, if I'm going to take this whole piece right here on the left from 0 to 1, if I want 1/3, I'm going to have to cut it into 3 equal parts. And I'm going to, okay. So in that case, this one section right here is 1/3. And then as I show more of these problems, the students realize, oh, okay, I'm simply cross-multiplying, but I don't want them to use that word though. But you do this enough with your students, they would figure what's going on, and they would now have a deeper understanding of the steps that you're telling them, rather than you just giving them the steps and say, well, this is how I've done it, or this is how I was taught by my math teacher, so we're going to do it like this. Now you have a more intuitive and more exploratory way of students solving a division problem. So then I'm going to divide this into thirds, this into thirds, the next section into thirds, this next section into thirds, and this next section is to thirds. So really each section produces 3 thirds. Okay? So then if I do that, so then if I have 6 sections, then how many of the thirds will I have after dividing it? Well, I'm definitely going to have 18, and you can go ahead and count if you want, but that is 18. 6 times 3 is 18. Now, if you do the long division way, you're going to do 6 over 1, and then you're going to change the operation to multiplication, and then you're going to flip the second fraction, and you see you multiply across, that's 18 over 1, or 18. So hopefully I was able to give you a little bit of a different perspective into looking into the division of fractions, which I think is one of the hardest skills, or one of the skills that students struggle with. They don't struggle so much with addition, especially when the denominator is the same. So addition and subtraction is easy when you're working with similar fractions. Now, once they understand this concept that I just showed you, you will find out that finding the least common denominator when working with addition and subtraction problems with unlike denominators becomes much more easier because now they visualize what you're trying to do. I'm going to skip this last question. Well, I think, yeah, we are running short of time. So I'm going to go ahead and cover the do's and don'ts of this, and then maybe if I have time, I can go back to that slide. So these are some of the things that I want you to do with your students. So I want you to just take a moment for some of you just to read with what you have on your screen. You know, think about some of the things that stick out to you. Some of these things we already do and I've already modeled to you in this webinar. And give lots of think time. One of the things that I, give my students a lot of think time, when they're struggling through fractions, I let them struggle. I let them figure it out on their own. I don't give them the final answer, or I don't affirm them as to, yes, you got the right answer, or no, it's wrong. I want them to struggle a little bit and figure it out on their own, because that's the only way they're going to understand fractions. If they work it out on their own, okay, if you came out with something bigger than what I expected, then I ask them, go ahead and show that to me. Can you draw that? If you come up with a half, do you think your answer is about a half? So I do some estimation things with them, and I do a lot of probing, but I leave all the thinking to the students. Again, delay using the fraction vocabulary, especially for your ESL learners. Don't let them get bogged down with the vocabulary. The vocabulary is there so that you can talk about the steps. So you can talk about the algorithm and you can talk about the rules. But if you're doing it in a visual fashion, you don't need the vocabulary. You don't need the vocabulary yet. You can delay that later on when students already have a much stronger grasp of fractions, and make lots and lots and lots of visual aids into different types of representations of fractions. Lastly, do not introduce fractions symbols too early. They must be proficient with their multiplication facts. They must be proficient with division as an operation, division with whole numbers. For some learners, they don't, some learners that are not very spatial and they struggle with illustrating fractions, teach them how to memorize rules, teach them some of these mnemonic devices that we have. There's a ton of those in the internet. Don't just teach them the memorization, though. Teach them the memorization with the illustration side by side, so that even if they can't draw it, they can picture it in their minds. Don't teach just halves, quarters. Don't do all of that, okay? You must introduce them to more complicated fractions like 7/8 or 11/13. Those fractions that result to repeating decimals, because those are the ones that they're going to be grappling with when they go into the GED. Do not allow learners to compartmentalize fraction or to see them separate from decimals and percentages. That's why I showed you those pictures earlier showing how decimals, percents, and fractions can be equivalent. or they could mean the same thing. And do not give them endless drills in practice, because that just turns them off. That just turns the students off on fractions altogether, especially if they're already struggling with it. If they're struggling with it, giving them more drill in practice will not help them. So before I do the summary, I wanted you to check out this website, the Illustrative Mathematics Project. Illustrative Mathematics Project is a website. They have standards, sample lesson plans which are quick and simple, easy to follow, and much more importantly, they have videos. They have videos that teach teachers how to teach fractions. They have videos, and you can even use the same videos to teach students. So sometimes I've seen teachers use the teacher videos and show them in class, and students get it and they understand, and I'm like, oh, well, this video can, I can't do the same justice to this video had I explained it myself. So sometimes I would do that as well, flip-flop between the two. This is just a great website, especially when your students are struggling with fractions, because they arrange in such a way how you're going to teach fractions in a particular order. So teach this first, then teach this, and then teach this, and it kind of builds the block of your understanding of fractions. It's really great. I've benefited a lot from this website, so please visit it. And we're going to put a link to that website on the IPDay website, as a summary, I just wanted to talk about that what we did is just recap and apply the content standards, apply the practices on the standards, look at some approaches to teaching of the fractions, apply this one particular mathematical practice, which is the MP4 modeling with mathematics, and then again, just like I said, all of these resources, including this webinar, is going to be recorded, and you can view this webinar again. I know I went over too fast over some of the concepts, but you can view this webinar again and for your own viewing pleasure. For those of you who have some questions, I will answer them through email. If you have any lingering questions there, I'll email you my responses. But what I need you to do at this moment is take a little bit of your time. I'd like to hear what you think about this webinar. I hope I was able to provide you a different thinking about fraction, or a different way to teach fraction, or especially for those students that you've tried everything and they still don't get it. Of course, some of your students will respond directly to traditional introduction and representations of fractions, or teaching of fractions. But this is just an alternative way for you to look at it. If you're not successful with the traditional way, try this, and maybe you'll get some success out of your students. Please try to visit this website, www.surveymonkey.com, and then just go into just type this in. You can also copy and paste it onto your browser if you want. If you have a smartphone, you can use your smartphone and use the barcode scanner to scan this code from your handouts that you can download. But again, hopefully I was able to impart some really, really useful tips and tricks to you in teaching fractions. I really appreciate your time. Thank you very much for participating in our webinar Wednesday. Until the next time, have a wonderful afternoon.